All right, we're going to continue with our work on solving two-step equations, and here we'll be looking at a challenge and a real-world connection problem as well. Okay, so the challenge problem we'll look at, by the way, maybe pause the video and take a look at both of these on your own first and see if you can give them a shot, see if you can get the right answer. But I'll go ahead and solve these right now for you. The challenge video, or the challenge problem here on the left side, 3 minus x is equal to -5. This was a little bit interesting to me because we're subtracting away an x. Often we maybe start with an x and we subtract away a number to get an answer, but in this case we're subtracting away an x to get an answer. So I'm going to show you a couple different options. My temptation first is to subtract 3 from both sides, but I will show you a different process as well. Whoops. Get that back. Okay. And this 3 and this -3 cancel out, and we end up with a -x is equal to a -5. Take away a 3 is a -8. After we do that, I can either multiply or divide by -1. It doesn't matter at all. I'm going to show a division by -1. And this negative and this -1 cancels, and we have x is equal to a +8 as our solution. And let's do a quick mental check to make sure. Is 3 minus an 8 equal to -5? It is. It does check out. And I want to show you another process here to solve that same problem for someone who might want to avoid negatives. Sometimes negatives trip us up a little bit, might be a little bit harder. And so we can actually do this problem without dealing with quite so many negatives. So let me rewrite the problem. Negatives are a good a concept idea to really work with in practice so that you're comfortable with, but it's certainly okay to try some easier solution pathways sometimes. So for this one, what I'm going to do, I'm going to actually add x to both sides. I think you'll see that this might be a slightly longer pathway. Maybe it's not. We'll see. But those x's cancel, and we end up with a 3 equals -5 plus x. Actually, this is still going to be a two-step problem, so this will work out just as easily as the other one. And then we can add 5 to both sides. And this -5 and +5 cancels. We have an x remaining on the right side. 3 plus 5 is 8. So we get the same answer through a slightly different process. And you can decide which one might be the route that you want to choose. All right, so for this next one, a little bit of a real-world connection. It's actually a real problem from when I was in high school. When I was between high school and college, I worked at a well-known soft-serve ice cream shop. I was paid a $50 bonus. I like highlighting the specific details here, for committing to the job for 10 weeks for the summer. I earned a just above minimum wage at the time of $5.25. The minimum wage is higher now. And I wanted to earn a total of $2,500 pre-tax over the summer. So we're not going to worry about income tax or other Social Security taxes that might be taken out of my paycheck. So it looks like I have a couple questions. How many hours did I need to work? And how many hours per week was that? Okay, so let's try to get this into a mathematical sentence here. So I want my total to equal 2,500. And looks like I'm going to be adding on a plus 50. That's going to be my bonus. And then it looks like I need to worry about my hours and my minimum wage. I'm actually going to define my variable first. I probably should have done that at the very beginning. Let x equal number of, let's have that be the number of total hours worked. I'm not going to worry about the number of hours per week yet. Okay, so let's let x equal the number of total hours worked. And I'm earning $5.25 per hour. So 5.25x plus 50 is 2,500. Okay, so we're not using the 10 weeks quite yet, but we'll get there. We'll get there in a moment. So I am going to imagine building an onion and then peeling it. It looks like the 5.25 is more closely connected to the x because of the multiplication than the 50 is. So I'm going to deal with the 50 first. That's an outer layer of the onion. Let's deal with that first. These 50s cancel. We're left with a 5.25x on the left side. 2,500 minus 50 is $2,450. Now we can go ahead and divide by the $5.25 per hour I'm making. So we can solve for x. And these guys cancel. We're left with an x on the left. We need to do 2,450 divided by 5.25. And I get 466. I'll round to the nearest 2 decimal places. I need to work 466.67 hours. That's a lot of hours I need to put in. In real life, you might want to just round that up to 467 hours. Okay, and let's actually do that. Let's assume my boss wants me to work a whole number of hours. So I need to work 467 hours. The bummer is I only have 10 weeks to do it in, so I'll have to put in a lot of hours every week. So we can say 46, just divide that by 10, 46.7 hours per week. Okay, so those are our 2 answers to the problem. So I need to put in about 50 hours a week over the whole summer to meet my goal of earning $2,500. Phew, okay. And that's a good place to stop right there.